Hello everyone, my name is Deborah Emeni. Thank you for having me. Today I'll be talking about demystifying the concept of ERC20 tokens, and I'll be using the Open Zeppelin ERC20 interface as a reference. So before I begin, I would love to do a brief introduction about the ERC20 tokens. So people use Ethereum to create tradable tokens, which are digital assets built by creating smart contracts on the blockchain. So these tokens aren't just created, they follow a standard like the ERC20 token standard that was proposed by a man called Fabian Fogelsteller, in November 2015. So using a token standard allows interoperability across other token applications, which I will actually discuss later in this tutorial. So to list a few of the existing Ethereum token standards, we have the ERC 721, which is a standard for NFTs, that's non-interchangeable tokens or non-fungible tokens rather. And also we have the ERC 777 token standard, which is for building extra functionality on top of tokens. And we have the ERC 1155 standard for creating utility tokens and non-fungible tokens. However, the focus of this tutorial is on the ERC20 tokens, as mentioned earlier, and the ERC 721 is a standard for creating non-fungible tokens, which are otherwise known as NFTs, while the ERC20, on the other hand, is a standard for creating fungible tokens. So what are fungible tokens? So fungible tokens, in simple terms, are tokens that store values that remain the same wherever they are used. So a typical example is a cryptocurrency like 1BTC, which is the same in whichever country it is used. All right. So non-fungible tokens store data of an item that cannot be replicated. For instance, we have a deed of ownership as a very good example. So moving forward, I would love to mention quickly or briefly mention some of the use cases of the ERC20 token before I start the demo. So the ERC20 token obviously has its own functionalities that distinguish it from the other tokens, right? And that is why people blockchain developers want to use it, all right? So one of I listed a couple of them, like just 4 of these cases, 4 of them that I think stand out. So one of it is approve if a certain amount of token can be spent by another account. Another is to get the token balance of an account. Another is to transfer tokens from one account to another account and to get the total supply of tokens available. There's no need to go into details explaining each of these use cases because it's as simple as it looks. Moving forward, I would love to do a simple illustration that would better paint a picture for you on how the ERC20 tokens works. But before I do that, I want to show you the Open Zeppelin, which is a tool that allows you to build secure decentralized applications. So it actually has an implementation of the ERC20 as an interface. What I mean is it contains the various methods as all right, let me show you. So it contains the various methods. All right. Right, sorry about that. So it contains the various methods as function declarations. So this is the Open Zeppelin, and this is like the GitHub repository that contains the contract, where you have the token, then you have the ERC20, and in within the ERC20 folder, you have the file called IERC20.sol. So this is a Solidity file because you have this .sol extension, which signifies that it is all the code written in here is written in Solidity programming language. So here we have the interface that I mentioned earlier that Open Zeppelin has, and And I mentioned that it contains methods as function declarations that a proper ERC20 token standard should contain. Here we have the interface, ERC20, event transfer, event approval, function total supply, function balance of, function transfer, function allowance, function approve, function transfer from, and so these are the interface can be implemented to create ERC20 tokens. So in simple terms, moving back to my illustration. So I'm moving back to my illustration, I'm trying to move this down so that I can see. All right, great. So moving back to my illustration, in simple terms, assume that there are two blockchain developers that want to create ERC20 tokens. So they can simply use make use of the code provided as an interface in the Open Zeppelin, and this would ensure that they both create tokens that are compatible with each other and interoperable across applications. So moving forward, let's quickly see a demo that would help you understand better the ERC20 interface defined in Open Zeppelin. So I'm going to be explaining what each of these functions do in detail, and how you can actually implement these function declarations that have been defined in this interface in the Open Zeppelin, and how you can implement them to actually create your own ERC20 token. So I'm going to be going in detail, explaining each of them so you have a better understanding of what you are creating, okay? So that's what I'm going to be doing now. Right. So now the first, I also, some of the use cases of the ERC20 token that I listed earlier are actual methods that can be seen in the code block that I showed you. So here you understand what each of those functions do in regard to their various use cases. So afterwards, you would create a token that implements the interface, right? So let's say the first one, which is getting this total supply of tokens. I mentioned earlier in the use cases that one of the use cases of the ERC20 token is to get this total supply of tokens, right? So it has a function declaration. The Open Zeppelin that I showed you right now in the interface has a function declaration for the total supply. So that's what I'm going to be explaining now. So what is it about getting the total supply of tokens? On your screen, you can see the function total supply, external view returns on-site integer 256. So this function returns the total number of tokens supplied in the contract. Notice the external and view qualifiers used in the function declaration. So the external qualifier makes the qualifier to only be called by other contracts that are outside of this contract when it is deployed. So the view qualifier signifies that the function does not change the state of the blockchain, and it just returns the total number of tokens that have been supplied in the UN256 type. So moving forward, we see another use case, which is getting the token balance. So this function balance of address, account, external view returns UN256. What it does is it accepts the address of the Ethereum account of the owner as an argument, which is this, with the address type, and returns the balance of its tokens as an UN256 type. Moving forward, we have another one, which is for transferring tokens. So here we have a function and an event, which I'll explain. So this function transfer address to UN256, amount, external, returns, and both. This function basically transfers for tokens from one account address to a different address, while emitting an event transfer address index from address index to UN256 value. So it basically emits an event which is tagged as this transfer event right here. So the function accepts two arguments: the address of the recipient, that is the receiver of the tokens, and the amount of tokens to be transferred as an U-in-256 type, right? So the caller of this transaction would most likely wait for the transfer event to prove that the transaction was successful, right? You would most likely wait for the transfer event to be emitted to prove that the transaction was successful. So this leads to a change in the state of the blockchain, and that is why you have no view qualifier in the function, right? So moving forward, we have another one for the spending of tokens of a different owner. So here you have a function called allowance with two arguments: address owner, address spender, external view returns, and it returns value of unsigned integer 256, right? So on the Ethereum blockchain, when a buyer needs tokens to be sold to him, the allowance function could be invoked. The function accepts two addresses as an argument. That's the address of the owner, which could be the seller, and the address of the spender, which is the buyer, and returns the number of tokens the spender can spend on behalf of the owner. So also note that this allowance function can be called by anyone and not just the spender of the tokens, meaning that anyone can invoke the function and be able to see the number of tokens that a certain owner allows a spender to spend. Moving forward, we have another one for approving a transaction. So the allowance above, which I just mentioned previously, can be created by calling an approve function. So this, we have an approve function here: function approve, address spender, U-in-256 amount, external returns, and bool. So this allows function can be created by calling the approve function, like I mentioned earlier. So the approve function accepts two arguments: the address of the spender and the address of the and the amount or the allowance of the spender. So then it returns a Boolean value on a successful transaction. So you also have the one for transferring an allowance. So now that the allowance is created with the approve function, right? Okay, I think I skipped one, the approving a transaction. Yeah, so right, so I mentioned the approve function. So I think we move forward to see the transferring an allowance. So now the allowance is created with the approve function to transfer the allowance from the sender to the recipient. Transfer from function can be invoked. So the function accepts three arguments: the address of the spender, the address of the recipient, and the amount. Then it emits a transfer event and returns a Boolean value indicating whether the transaction was successful. So thus far, you have seen some of the essential methods of the ERC20 token standard that have been defined in the interface with their use cases. So next, we're going to be doing a demo. We're going to be building a contract that uses this interface to create tokens based on the ERC20 token standard. So it's going to be like a hands-on demonstration, and I'm going to be showing you how to create a token implementing the ERC20 interface that you'll be using. And I'm going to be using a Remix ID editor. I'm going to be using a Remix ID editor to actually build this contract. So the first thing you do is to open your Remix IDE and create a file. And here I already have created a file. Yeah, sorry about that. I already have created a file. Yeah, called token contract.sol. So it has this .sol extension showing that it's a file that's created with the Solidity programming language. So I'm gonna be adding an interface. So basically, I'm going to show you how you can do it step by step using the Open Zeppelin. So I'm going to be creating another contract to show you how this can be done. So we could probably call this ERC token contract .sol, right? So that's SOL. All right. So here the first thing is is to add your license. So you have your license. I'm going to be referring back to what I already have here to save time. So we have the license and the pragma. So you just add them here, over here. So the next thing would be to define your interface, right? So you have the interface already, and this interface is coming from the Open Zeppelin contract. So here, and if you go to the Open Zeppelin in the GitHub repository, Open Zeppelin contracts, Open Zeppelin, that goes to Open Zeppelin contract repository here, and you go to the contracts folder, navigate to the token folder, the ERC20 folder, and then you have the ERC20.sol file. So in here you have the interface, right? So this is your interface. So you have your interface. So we're gonna just copy, we'll just copy this. You actually could just copy this interface here, right? And in the Remix ID, just use the interface right here. So yeah, we have a lot of documentation here. So to actually just explain what each of them are doing, but I think I've already done that, so there's no point, but I can leave the documentation there, right? So right, so this is the interface created. So the next is to create the contract from the interface, right? So we're going to create a skeleton for the contract with the contract keyword, and we're going to also use an is keyword to show that you're using the interface that has been defined above, called the ERC20 token. So what we're going to do basically is do this. We're going to say contract, the name of the token is ERC20. So that's what we're going to do. So here you have the contract. Oh, I see I didn't copy anything. So I'm going to go back and copy it again. I can actually type it out, but to save time. Yeah. So you have this. So I'm going to be calling this ERC20 ERC token contract. So I'm going to call it. So right. Close the contract. So here we have our contract skeleton, right? So we're going to start by defining a safe math library that actually what it does is it reverts a transaction in case of an operation overflow. And it's tagged to the, it worked for the unsigned integer 256 type, which is what we're going to be using for a total supply and other return values. So in case we have like an operation overflow, we can, the safe math library is going to help us revert the transaction. So that's what we're going to, that's the first thing we're going to be defining here. So we have the safe math library, which is this. We're going to be defining it right here. So we have the safe math, and then the next thing is, so this safe math actually uses a library, and if you navigate back to the Open Zeppelin contract, this time around, you go to the ERC20.sol file. What you're gonna see is a library right at the bottom of the contract. I'm scrolling down to the bottom of the contract. Okay, what can I see here? Right, that's interesting. Okay, right. All right, I think I would have to find that, but to save time, I'll just go back to the Remix IDE and I'll show you the library we're going to be using for the Safe Math library. So the Safe Math actually has its own, I think I can find that, Safe Math library, Safe Math library, right. So I don't know if it's this. I think. So I think this file actually explains how the functions that I'm going to show you in the library, what it does and how it works. And I'm actually looking for the repository. Yeah, so I think this is it. where you can find the Safe Math library. So here you have so still in the Open Zeppelin contract repository, you find in the contracts folder, you have a utils folder, and then you have a math folder, and you also have the safemath.sol file. So in here you have the library. So library safe math, and this function is for try-add, function is for try-sub, function is for try mul, and try-diff, and the rest of them. So what we're going to be using is just these two functions for add, functions for sub. Okay, so referring back to the Remix IDE, we're gonna I already have it here, so I'm just gonna copy the library, right? Yeah, so I have the library here, so I'm just gonna copy it. Right, so this is the Safe Math library that you have here, right? So we're gonna copy this library. We're gonna paste it right here. Oh, sorry about that. That should come after, I think, outside of the contract. Yeah. So it should be outside of the contract itself. So back to your ARC, back to your contract. The next thing, you're gonna define the state variables. So to identify your token, you need a name and a symbol. To define a name and symbol for your token, you can create so basically, to increase the readability of your token, you need like a name, you need a symbol for your token. And to do that, you have to define a name and a symbol for your token. And to do that, you can make use of the state variables that come in handy with Solidity, right? So as also, you're also going to be defining decimal places. So by default, 1 ETH is 10 raised to the power of 18 way. So you can also define the number of decimal places for your token as the default 18 decimal places by creating a state variable. So we're going to be creating a state variable for each of them. Here, we're going to basically create these state variables here. So we have this. So for the, so moving back to the, yep. So we have a state variable for the name, we have the symbol, and we have decimal, and they're all the private qualifiers and all of that. So notice that we're actually defining the state variables as private, which means that other contracts cannot read the variables, but you can also decide to set them as public, actually, depending on what you choose. So the next thing we're going to do is to define the mappings. So the next to define the mappings that would store the balances and allowances of the token as key value pairs. That's what we're going to do next. So you have the mapping, and I'm going to explain what each of them do. Yeah, so we have a mapping right here. So so the first mapping created here is it's basically for the token balances, right? It's basically for the token balances. And what it does is it stores the balances of the tokens with their respective addresses as the key values, right? And the value of the balance is going to be stored in the UN256 type. Then the second mapping, which is this, is for the allowances, right? So the allowances, and what it does is it specifies the amount of tokens to be spent by another account defined by its address. So basically, the value of this mapping will be the value of this mapping will be another mapping. As you can see here, we have another mapping here, and where the first key or the index, which is this, is for the account owner, and the second index or key is for the spender account, right? So moving forward, we're going to define the variable for the total supply, the state variable for the total supply, right? So that's the next one we're going to do. So the total supply here, we have the private total supply here, right? So defining the variable for contract. So the total supply of tokens was explained, I explained earlier when the interface was, when I actually discussed about the interface. So now you need to define a variable that would keep track of the total supply of tokens, and which is what we just did. So the next is to define the constructor. So when a contract is deployed or created, you would want to name your token, add the symbol and decimal places. So you can achieve this by creating a constructor that would actually accept 2 arguments. So let's see the constructor right here. So this is the constructor we're going to be creating right here. So this is the constructor we're going to be creating. So this constructor basically, what it does is it accepts 2 arguments, the token name, actually 3 arguments, sorry, the token name, the token symbol, and the total. So basically, right. So what we're doing in this constructor is we're setting the state variable, which was declared here. We're setting it to the token name, passed in as an argument in the constructor. The same for the symbol, the same for decimals. And then for the total supply, we're actually multiplying it by 10 raised to the power of 18, multiplying the total argument as to 10 to raised to the power of 18, and which is, like I mentioned earlier, the amount of weight that one ether has, right? So the next one is what we're doing here is we're actually setting basically we're setting the token balance of the owner to the total supply of tokens. That's what we're actually doing here. So this message is saying that basically the address of the caller of the transaction. So the balance of the caller of transaction, remember that this balance is actually coming from the mapping here, right? So it's actually storing the balances of the owner with the address type. So basically you're passing in an address, which is a message, msg.sender is actually an address, right, of address type. So that's what this is, right? And we're actually setting it to the total supply of tokens that has been multiplied by 10 raised to the power of 18. So that's what this constructor does. And remember, I said that the constructor is actually, once the contract is deployed, the first thing that will be called is the constructor. So that's basically what it is. So moving forward, we're going to be creating functions that actually display information about the token. So after the constructor, we have another, we're going to be declaring several functions here. So I'm going to be starting with the one for the name, the symbol, and the decimals. So here we have the function that actually, so like I said earlier, to improve the readability of your contract, you can display the name, the symbol, and decimals of your token. And to do this, you need to create functions that when called, will return all of these. That's the name of the name that has been set, right? Once the constructor is, once the constructor is actually called, once the contract is deployed, constructor is called, so this name is going to be set, symbol is going to be set, decimal place is going to be set, and all of that, right? So actually, I don't think there's any point for this, but whatever, because we're actually still setting it. So whatever. So just moving forward, we have the name, symbol, and decimal. We have functions that are actually setting the name, the symbol, and the decimals, right? So moving forward, we have also, I would like to point out that we have been storing the return string for the name and symbol in memory. And what that means is immediately after a function called, the name and symbol will be stored in memory, which gives the contract a read and write access only. So that's why we're actually using the memory here to store the store the name and all that. So next thing is we're going to be defining functions for getting the function. We're going to define a function for getting the total supply of tokens. So to read the total supply of tokens, you can create a function that actually returns the total supply of tokens. So this function we're going to define right away. So for the total supply of tokens, we have this, right? So right here you have this, and right. So we have this. So what this does is, as you can see, you have like an override here used. So what is doing, this override is doing is it allows you to override the other total supply function that was defined in the interface. Right, in your interface here, you have a total supply that was actually defined, right? You have a total supply that was defined. Yeah, this total supply was defined in the interface. So you're actually overriding it creating your own. It allows you to basically create your own total supply function. Yeah, so that's what we're doing. And what it's doing is returning the total supply that was defined as a state variable here, right? So that's what it basically does. So moving forward, we're gonna be creating another function that returns the token balance. That's the account tokens balance. So it basically accepts the owner of the token's address as an argument. So here we have the balance, right? So we have the balance. Okay. So here you have the balance. And right. Oh, sorry about that. Okay, so we have the balance. So notice this wasn't indented. So I'm just gonna indent it. Hey, that's so much. So I'll just indent it a bit. All right, so what this does is, as you can see, it accepts the owner of the token's address as an argument. It actually accepts the address of the owner as an argument, and then it returns the token balance of the account using the balances market that we actually defined earlier. So that's what it does. So the next thing is, so basically what this balance of does is it allows you to transfer the number of tokens from the sender to a recipient with two parameters. The right. So with the two parameters actually, right? Right. So I'm going to show you the event that will be emitted, right? I already showed you the event, the transfer event that's actually emitted whenever this function is called, right? So moving forward, we're going to see the transfer function. So basically, well, I think I have skipped. All right, cool. So I kind of skipped something. So right. So let's create a function called transfer that would contain the next one we're gonna do is create a transfer function that would actually allow us to transfer tokens, right, from the sender to recipient with two parameters: the address of the sender and the amount to be transferred. So that's what we're gonna do now. So here we have the transfer function, and we have transfer function. So right. So here we're gonna put the transfer function. So basically, this accepts as like two arguments, or let's say two parameters. It accepts two parameters: the address of the sender. What am I saying? The amount to be transferred, rather. Right. I think this should be sender. So the amount parameter is the amount that the sender of the token must at least have. And within the function, you'd also need to call the transfer event, and at the end of the day, like, so basically this function emits the transfer event that we defined earlier. So the function will contain the owner's address that is specified with the msg.sender, the recipient's address, and the amount sent, and returns a boolean value of true, right, as for a successful transaction. So now we're going to create this transfer function that is actually used here. So we're going to create right below. Okay, so here I have my transfer function. So this is transfer function, right? So the transfer function I'll actually use. So this is transfer function. Okay. So I have so much indentation here, so I'm just gonna do a shift tab. Right. So right, we have the transfer function that's actually used here. So what you did is here, we created a transfer function that accepts three parameters: the address of the sender, the address of the recipient, and the amount to be transferred. And the internal virtual, which is used here, allows inheriting contracts to override the behavior of the function. So the required keyword also used here, basically what it's doing is a condition that checks if the address of the sender or the recipient is 0, and if it does, it throws this error saying you cannot transfer from 0 address. And also it does the same for this. So if the address of the recipient is also 0, it says you cannot transfer to 0 address. So yeah, so basically it sets the balance of the spender to a variable called from balance, and checks if the balance of the spender is greater than or equal to the amount of transferred. So if it is greater or equal to the amount, it throws an error saying transfer amount exceeds balance. So the unchecked here basically performs the same function as the safe math library I mentioned earlier. So basically here you're subtracting the amount of the balance of the spender, right? So then you're actually setting the balance of the recipient to the amounts here, right? So the transfer event is emitted on the successful transaction. So let's move forward to creating this allowance, right? So let's see how this allowance can actually be created. So the next thing we're going to do is create an allowance function that returns the number of tokens the spender can spend on behalf of the owner. So here we have the right. So we have the allowance function here. So this allowance function is what we're going to be using. So here we have the allowance function, right? So to create the allowance, basically, we are going to write an allowance. So this is basically the allowance function, and it's as clear as this. So we're just going to move forward to create the allowance. So to create the allowance, we have to write another function called approve, and that's what I'm going to show you right now. So this function approve, right? So this function approve is what we're going to be using. Right, so basically what this does is it accepts the address of the spender, the amount that has been basically the allowance, and then it transfers the amount to the spender from the address of the sender. Call out transaction. So the next thing is spending the allowance. How do you actually write a function that will actually allow the allowance to be spent? So you have to create another function that would accept the addresses of the sender and recipient, and also the amount being spent, and then call the transfer function. So that's what we're going to do now. So here we have another function called transfer from, right? So so transfer from. So we have the transfer from. So right. So it accepts the address of the sender, the recipient, and the amount being spent. So it calls the transfer function here to spend the allowance and subtract the amount being spent from the allowance. So the approval event will be emitted upon successful transaction to show that the allowance has been updated. So the first thing that happens is this function is the transfer function that is called transfer the amount specified as an argument from the sender's address to recipient. The next thing you do is to create the approve function that is used here. So the approve function that is used here is what we'll be creating next. So we have the approve function here. Right. Have so many indentations. So the approve function is similar to the transfer function, and similar to how the transfer function works. So it's called with the address of the caller of transaction, followed by the address of the spender and the allowance. Then it uses the sub. It uses the sub function in the safe math library to subtract the amount that is being transferred from the allowance that was approved. Then it returns true on successful transaction. So once you have that, I think that is all you actually need. So you can go ahead and actually deploy your contract. First of all, you have to compile it, right? So before you compile it, ensure that you have your MetaMask
so that you have your MetaMask connected, right? So you have your MetaMask connected. So here I have my MetaMask connected to RinKB test network. And then next thing you can do is to compile this contract by clicking on this compile button. And then you have your contract compiled. You see this green tick showing that your contract has been successfully compiled. So the next thing is to deploy the token, right? So if you go to this tab here, you have you can click the deploy button basically here. So I'm going to be using the JavaScript VM to deploy this token, and then I'm selecting the ERC22, basically selecting the contract that we're working on, and then I want to click on this deploy. So before I do that, actually, before I deploy this token, I would want to set the name, the token name, token symbol, and the total, right? That was actually set in our constructor. So basically, let's set the name of our token to, let's say, ERC token, right? And then set the token symbol to ERT, and then the total amount of ether, let's say we're want to send like initial amount that ether should be like 1,000 tokens. So we click on the transact button, and here we have a green tick showing that it has successfully, been deployed. So here we're going to see our deployed contracts. So these are deployed contracts right here. Have a deployed contract right here. So that is how you can actually use the interface in the Open Zeppelin to actually create your own ERC20 contract. So basically, you've come to the end of the tutorial where you created an ERC20 token using the Open Zeppelin interface, and you also learned the use cases of the method or function declaration in the interface, and how to implement them while creating a token. So that's it for now. Okay,